Hello folks, we are back with our next video on this approximation. Last time we were doing the approximation and we were taking a y, then we were taking x dependent on that y, and then we were doing it in that stereotype fashion. Now from this question number 2 onwards, it's going to be a slight change in the way that we were working last time. Let's see how the change is. Let's go through the question number 2. Question number 2 says that find the approximate value of f of 2.01 where f of x is given as 4x squared plus 5x plus 2. So here it's no y and x business, it's all f of x business. They have given us a function f of x and they have defined the function f of x and they have told us to find out the value of the function at a particular value of x. And for that we are going to use the approximation. We are going to find out a value which is close to that value and then we are going to check how the values are going to come. So they give us that f of x is 4x squared plus, I'll check the function once again, it is 4x squared plus 5x plus 2. This is the function, 4x squared plus 5x plus 2, and they ask us to find f at 2.01. Let me just check if it's correct. F at 2.01, that's a question. So as usual, like how we used to tell, f of x is already there, so let's find out the f dash x, then let's take the x, let's take the x plus delta x, the same procedure, but then y is getting replaced by f of x, that's all. So let's proceed with that absolute same way as before. Since f of x is a consider, they have given us. So consider the f of x, which is 4x squared plus 5x plus 2. Let's quickly get the f dash x from here, which is the derivative, and derivative for x squared is 2x, for x it's 1, so it's 8x plus 5, which comes as a derivative. Now as usual, we will get our x values. X has to be, obviously we have understood, it's going to be a standard value which is close to our required value. Our required value x plus delta x is 2.01. So our value has to be obviously a standard value close to it is 2. Something that is easily calculatable. So let's take the x as 2. So obviously our y now is f of x, and f of x obviously by the definition is 4 into 2 squared plus 5 into 2 plus 2. I hope the change is noticed. In the earlier case, it was y, here it is f of x. It's absolutely the same as we have done before. So let's check now what this is coming. This is 4 into 4, 16, plus 10, 26, 28. Yeah. And x plus delta x is our required value, which is 2.01. So f of 2.01 we will calculate. Since you know x plus delta x and x, so you can always find out delta x, and delta x is x plus delta x minus x, which is 0.01. Now we, like before, there we said that dy by dx into delta x is y plus delta y minus y. Same kind of condition we will derive here. We will also, to be on the safe side, we will just also find f dash at 2 and 2. So that will be easier. In the next step, it will be very easy for us. F dash at 2. F dash we know. So f dash at 2 is going to be 16 plus 5, 21. Easy only. So let's now come to that step. F dash x into delta x is f dash f of x plus delta x minus f of x. See, this was our same thing now what we did there. Y plus delta y minus y is dy by dx into delta x. Exactly the same. Only the way of writing has changed. So it's exactly, that relation is exactly the same as we wrote there. But now because here dy by dx is becoming f dash x and all that, we are making that replacement and we are writing it like this. And all these things are there with us. We are quickly going to substitute and get the answer. F dash x for us is 21. And delta x for us is 0.01. F at 2.01 we have to find. And f at 2 we have found out, it is 28. So it's going to be very, very easy for us to find out f at 2.01. F at 2.01, 28 is going on the other side. 28 plus 0.21. Now 21 into 0.01 is 0.21. We can add it up very easily and it comes to 28.21. That's it. That's our answer. F at 2.01 is 28.21. That's about it. quite easy, and on the basis of the same thing we can also go. Third problem is very identical to the second problem, so you can quickly take that. It goes on the same wavelength as the second one. The third problem says that the function is x cubed minus 7x squared plus 15. You have to find the approximate value of f of 5.001. So let's check how that can be done. They give us a function. Let's start no right away. Consider they give us a function f of x as x cube minus 7x squared plus 50. X cube minus 7x squared plus 50. And they ask us to find out f at 5.001. That we can see later. Maybe I'll make a mention 5.001. So that will allow us to take the x and all that. Anyhow, right away let's find f dash x. F dash x for us, x cube we all know derivative is 3x squared and x squared derivative is 2x. Like that you have 3x squared minus 14x. That is our f dash x. Now, having got this f dash x as before, let's find the x. It's very clear to us because that x plus delta x value is 5.001. Obviously, our x is going to be 5 because that's a standard value which we can easily find. So, let's take the x value as 5. So, what is going to be our f of x? F of x is going to be 5 cube minus 7 into 5 squared plus 15. 5 cube is 125. 5 squared is 25 and 25 into 7. I wonder how much is 25 into 7. I'll quickly calculate. 25 into 7, 35, 3 carries. 14, 17, 175 minus 175 plus 50. We could do it whatever way you want. Either you add these two, then subtract whatever. So probably I'll go to add 125 plus 15 is 140. 140 minus 175. Minus 140 is going to be 35. So it's minus 35. F of x is minus 35. Now x plus delta x for us, because that's what they have asked, 5.001, which quickly gives us delta x also 0.001. This there's no need to mention. It's okay. It's understood. Now once this is there, we'll quickly find out f dash x also, or f dash at that particular value, f dash at 5. So when x is 5, or you can write f dash at 5, whatever. So same way. How much is that? That is f dash. So that is 3 into 5 squared minus 14 into 5. 5 squared is 25 into 3 is 75. And 14 into 5 is 70. So this is going to be 5. All the values are there. So like before, now we are going to quickly make the substitution and get the answer. It's only that much. Hardly anything. We have this, this now business. Let's put that now thing. F dash x into delta x is f of x plus delta x minus f of x. So so that's 5, and delta x for us it's 0.001, and f of x plus delta x it is 5. F of 5.001 that we have to find, and f of x we have found out it's minus 35, so it will become plus 35. That's a bit of a problem. Let it come on the other side. You have to find f of 5.001. It's a positive value. When it comes on the other side, it will become negative value, and this is easily multipliable. So it's 0.005. That's it. Now it's a matter of subtracting, though you can see the sign. So it is subtracting and putting the sign of the bigger number. So let's practically subtract and find. 35 minus 0.005. 5 becomes 4, 10 becomes 9, 10 becomes 9, 10, 5, 9, 9, 34.995. So your answer is minus 34.995. That's the value of f of 5.001. Very easy and very convenient. Once you're okay with this relation, then things are really easy. So it's just that same relation that we're catching hold of, only we are replacing it by f. That's all. Everything else is just like before. So that's about it. And with 2 more new problems, we can come in the next video. Thank you.